Hi everyone! So yesterday we learnt about what equivalent fractions are. Today we're going to learn to understand why some fractions are equivalent. So by the end of today's lesson, I want you to be able to explain why fractions are equivalent and explain how to find equivalent fractions from a given fraction. As you can see, I've got a piece of paper here and I've split it into two equal parts and I've shaded one of them. So I've got 1 out of 2 equal parts, which is 1/2. I've shaded in 1/2. Now, if I want to find an equivalent fraction, I could fold this piece of paper in half again. Now you can see I've got 2 out of 4 equal parts. So my equivalent fraction to 1/2 is 2 out of 4, which is 2/4. On this side, I've shaded in 1/2 of the paper, and on this side, I've shaded in 2/4 of the paper. The fractions are equivalent because you can see that it's the same amount of the piece of paper. I haven't coloured in any more parts or taken any away. By folding the piece of paper again, the number of parts that the whole piece of paper has been split into has doubled. So it started off, I'd split the paper into 2, and then I folded it again and the whole piece of paper had been split into 4 equal parts. So it started off by just being split into 2, and then by folding it again, it ended up being split into 4 equal parts. So the number of parts that the whole has been split into has doubled. But then at the same time, the number of pieces that I've got has also doubled, because I started off with having 1 out of the 2 pieces and finished with having 2 out of the 4 pieces. So the number of pieces that I've got has also doubled. So fractions are equivalent when the number of pieces that the whole has been split into, so the denominators, increase at the same rate as the number of pieces that you've got. So if the denominator doubles and the numerator doubles, then the fractions will be the same, because you're saying that you've got the whole has been split into more parts, but at the same time the number of pieces that you've got is also more. Let's look at this again. So here I've got 2/4. If I fold the piece of paper lots of times, let's see if I can make an equivalent fraction. I started off with 2/4, and now I've got a different fraction. So I've got the whole has been split into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The whole has been split into 16 equal parts, and I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 of them. So 2/4 is equivalent to 8/16. I didn't add any extra parts. I didn't take any extra away. So it must be the same fraction. Let's have a look at why it's the same. So the number of parts that the whole has been split into has increased by how many times? 4 times 4 is 16. So it's increased by 4 times. The number of parts that I've got has also increased at the same rate. 2 times 4 equals 8. So it's got bigger by 4 times. So if the denominators are increasing and the numerators are increasing by the same rate, the fractions will be the same. They will be equivalent. Why don't you have a go with a piece of paper? Start with a plain sheet of paper and fold it into quarters. Shade in 1/4. And then fold your piece of paper into more equal parts to see if you can find equivalent fractions to 1/4. Off you go. Once you've done this, open it out and see if you can find see if you can write down a fraction that is equivalent to 1/4. So for example, you might have written 1/4 equals 2/8. Can you check this by looking at how much the denominator and the numerator have increased by? Have they increased by the same rate? So how much has 4 been multiplied by to get to 8? How much bigger is 8 than 4? It's 2 times bigger because 4 times 2 equals 8. Has this increased by the same rate? Is 2 times bigger than 1? Yes, because 1 times 2 equals 2. If we look at this pizza, if I was lucky enough to be able to eat all of these pieces, let's look at what fraction of the pizza that is. So my whole has been split into 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. So if my whole has been split into 8 equal parts, I've got 1, 2, 3, 4. 4 of them. So I've got 4/8. 4 out of 8. But it looks to me like that pizza, that section of the pizza, is half. So I think 4/8 is equivalent to 1/2. Let's check to see if this has decreased at the same rate. 8 to 2. How many times smaller is 2 than 8, I know that 8 divided by 4 is 2. I know that 2 times 4 is 8. So, divided by 4. How many times smaller is 1 than 4? That has decreased by 4 times as well. So you can see that the fractions are equivalent because this has decreased, the denominator has decreased at exactly the same rate as the numerator. So it doesn't just have to be, equivalent fractions don't have to just be increased. They don't have to always be bigger. They can be smaller. As long as the denominator and the numerator are divided by the same number, then the fraction will be equivalent. Okay, Kingfishers, now it's over to you. I want you to come up with a fraction, any fraction you like, and try and find an equivalent fraction. So you do this by multiplying or dividing the denominator and the numerator at exactly the same rates. So here you can see I've multiplied the denominator by 3 to get 18 and the numerator by 3 to get 15. I've multiplied both the numerator and denominator by 3 to make sure that the fractions are equivalent. Then underneath I've drawn, you can see I've drawn 5/6. I've drawn 5 out of 6 equal pieces. Underneath I'm then going to prove that 15/18 are equivalent. I'm going to do this by splitting each box 3 more times because I've increased the number of parts the whole has been split into by 3. Now you can see I've drawn my 15/18. So I've split I've split this whole into 18 equal parts by splitting each of these boxes 3 more times. And you can see I've shaded in 15 of them, which is exactly the same amount as 5/6, as long as the whole is the same size. I want you to have a go at doing this in your learning journals. So come up with a fraction of any size and represent that fraction by drawing it out. Then try and find an equivalent fraction by multiplying or dividing the fraction by the same rate for the numerator and the denominator. Once you've done that, draw another hole, exactly the same size as the first one, but this time you're going to split it into more or less parts. And try to prove that your fractions are equivalent. I'd like you to do this for 5 or 6 different fractions and then send it to Miss Stewart. So hopefully now you understand why fractions are equivalent, and in that you are splitting the number of parts that the whole has been split into more or less parts, and the number of parts that you've also increased or decreased at the same rate. As you start drawing this out and doing your task, hopefully you'll begin to see this a bit more. Hopefully you can also explain how to find equivalent fractions. So if we've got 1/2, we can find any equivalent fraction as long as we multiply or divide the numerator and the denominator by exactly the same number. Well done, Kingfishers. I can't wait to see your wonderful work.